Welcome to the Rare Earth Elements podcast. I'm your host, Bridget Scanlon, from the Bureau of Economic Geology at the Jackson School of Geosciences at the University of Texas at Austin. In this podcast, we discuss rare earth element feedstocks with experts from academia, industry, and government. The discussions include a variety of potential feedstocks, particularly waste materials, and innovations in processing technologies to improve rare earth element supply chains in the US. I would like to welcome Brent, Elliott, and Julia Gale to the podcast. Brent and Julia work with me at the Bureau of Economic Geology, which is the state geological survey in Texas. And it's also an organized research unit within the University of Texas. So Brent's research focuses on mineral resources, and Julia's has emphasized fracture systems and geology related to energy production. Today, we're going to focus on rare earth element potential in Texas and broaden it to other mineral resources in the state. So thank you both for joining me. I really appreciate it.
Well, thank you for inviting us.
Sure. Happy to be here.
So the Bureau is extremely interested in evaluating the mineral resources in the state. And Julia, you have been leading an effort to develop a report on current status and also developing a web portal to access data and visualize spatial variability on mineral resources. Would love if you could describe a little bit the report and what it will include and who the target audience is supposed to be.
Yes, well, thanks, Bridget. This is part of the Bureau's Texas Imperative, where we're trying to look at some key resources and activities in the state. And ours is going to be called Economic Mineral Resources of Texas. And as Bridget mentioned, it's going to consist of two components. There's firstly a report of investigations, which is a style of Bureau publication that's been done for many, many decades. And we will have that report of investigations, and then in tandem with that, we're trying to develop an online resource for people so that they can view information and maps and other elements of interest surrounding mineral resources in Texas. But then in addition to that, the way that we're going to host it means that there will be an opportunity for people to be able to download databases. So that will be a very interesting and useful aspect. And you mentioned the question of who our audience is. It really is pretty wide. So we're interested in being able to communicate to all stakeholders. So it goes from the subject matter specialists through government people, through academia, and of course industry. And so it's really trying to cover everything, which of course is really a hard thing to do. But we're going to try to design it so that a general member of the public, for example, could go on the Bureau website and get some information. They might not want to get to the point of downloading a database, but they would nevertheless benefit from being able to see the range of mineral resources across Texas and see some maps and general information. So we're going to be hosting that on an ArcGIS portal, which will allow for us to do the things I mentioned. And the aim for our team, and it's a nice team. It's around about 6 to 8 people that have really contributed consistently, and we've brought other people in just to do very specific things. And we're trying to be ready by the end of 2025 with the report, and of course the online portal hopefully will be maintained on a periodic basis so that the material on there is up to date. And so, coming to the scope of what we're doing, it's pretty large. It includes all the mineral resources, barring oil and gas, hydrogen and helium, because they're being covered elsewhere. And I can, really describe a little bit about the key chapters. The first will be an introductory chapter that gives some historical context and also some regulatory information. And then the big meat chapter is chapter 2, which is called The Major Resources of Texas. And that's two big big subsections, the first one being industrial minerals and materials. And that has 12 subheaders in there. So it's everything, all the sand, gravel, dimension stone, salt, sulfur, all kinds of things go in that industrial minerals grab bag. And then we have the critical minerals subheader, which is a big one. That's got 19 subheaders currently, of which rare earth elements is one. Now, given that this is such a huge kind of range of things to write about, each topic is not covered, extensively. It's got links to information, to data sources and to publications, and then, of course, to some maps and things like that we would take from the online portal. So we have additional chapters in there on coal, lignite and rare earth elements from coal waste. And I know that Bridget and Brent are going to talk about that in much more detail, but it's going to be in there. It's going to be a short segment because, our overall RI is very long. We also cover uranium, lithium, and we have a section in there, lithium from brines, and metals that are not already in the critical minerals group. Then that's kind of covering the data side of things, I suppose. And then we have some chapters that expand on the topics of economic viability of resource development, socio-environmental economic impacts of resource development, and then new exploration, mining and processing technologies, and then another chapter on new opportunities, which can include heavy minerals from coastal sand. That is a small chapter in there. And then also kind of different from all the other topics is development of a workforce that's going to do all the work needed to be able to make sure that we have the materials that we need. So that's really the scope of it. It's quite large, and we hope that people will read it, and it will be available from the Bureau bookstore for sure once it's published. And then there's the online.
Right. Thank you so much, Julia. I know that's a huge effort, and I really appreciate all your work on this. And I was very impressed with the GIS portal and being able to see the distribution of many of these industrial minerals and others. And what was surprising to me when I read some of it was the value of some of these products. I mean, aggregates in Texas, I can't remember the exact number, but I mean, it's huge.
Yes. And I'm not going to comment on numbers because I'll get my millions and billions mixed up. But certainly it's a very, very large number.
Maybe Brent can chime in here.
It's exceeded over 10 billion in revenue these days for aggregate materials.
Yeah, I didn't realize that before I read that. And then you mentioned lithium. And of course, there's the huge interest in lithium these days, and East Texas and the Smackover. And I think maybe Brent will talk about that in a little bit. And also uranium. Brent and I visited a proposed uranium nuclear plant. A nuclear plant in Abilene last week, Abilene Christian University. That was very interesting, wasn't it, Brent?
Yeah, that's the small modular reactor using molten salts, right?
Yeah.
Lithium, beryllium, zirconium, fluoride, salts. They're pretty interesting project going on. It's they're in a small scale now. What, 1 megawatt was it? And then they're planning on scaling that up. So it's going to be an impressive thing once the scale up happens.
Yeah,
right.
We have a little section. We have a little section on that in the RI.
Oh, great. Yeah.
Yes.
Yeah, that's super. Rusty Towell gave us a tour, and it was very interesting. And it's a research reactor, so they're not actually producing energy. It's about 1 megawatt scale. But they're looking at the various issues. And that technology was used in Oak Ridge in the 60s. So it's not a new technology, but they're reviving it. And then the scale up, I think they mentioned, Brent, was 100 megawatts in the Permian Basin. And part of it to deal with treating produced water. So this is fascinating.
Yeah, it also had medical applications for isotopes that it could produce, which I had no idea about until we took that tour. And so that combined with water treatment and then energy, that's all aside from the energy possibilities. It's really, really impressive and innovative.
Yeah, really good job up there. So Brent, you and I have been involved with the Department of Energy Carbon Ore Rare Earth Critical Mineral Project since about 2021. Part of the Bureau led the Gulf Coast program. And initially, this program was focused on coal and coal waste or ash from power plants. But then in the middle of it, they broadened the scope to include other feedstocks for rare earth elements. So, Brent, maybe we can start with trying to describe the coal resources in the state.
Right. So, Bob Reedy, who was here at the Bureau, put out a publication that's gotten, a lot of attention from scientists as well as just the public and press. Pretty impressive work that he did there in kind of assessing the resources in the Gulf Coast area for our lignite material, right? Our lignite that we mine here in the Gulf Coast area compared to, bituminous coal or other kind of coal streams from around the U.S. We're pretty much focused on the low grade material. I think what was his account was about 83 gigatons of coal mapped in the upper 100 feet of the surface. Within some the Wilcox area is our primary formation that has coal here in Texas, for example. All right, it's all low maturity coal, brown coal material, or they should call it dirty coal, even though it's you can still burn it. We have certain kinds of power plants that are set up strictly to use that kind of coal material, like the San Miguel power plant down south of San Antonio. But we estimate I think the assessment was over 30,000 drill holes, right, that were assessed. 40% of the resources in Texas are from that material. But most of it's all open pit mining, strip mining, and that's been occurring in Texas over, way up to 50 years at least of mining here in Texas. During the heyday, I guess back in the 90s or early 90s, we had about 29 different operations just here in Texas, not including the rest of the Gulf Coast. And I think we're down to about, 6 or maybe even less than 6 now, as the decline of the coal industry in Texas has slowly happened. And I guess even more so happened in the last decade or so, as those mines start to run out of material and resources and start to close up operations. We've had a number of power plants that have kind of shut down, sometimes incentivized by solar power and wind power and alternative energy sources that are coming online. So it's an interesting time for the coal industry here in Texas currently. But this is almost a revival now of assessing all of the waste material. It's not just a resource, but then now we have the waste material as a resource, as we've shown in the publications that you have put out with the concentrations of potential rare earth materials, right, critical minerals.
Yeah. So, I think the big push on coal happened in the 70s during the energy crisis. And then a lot of coal power plants were built, and the mines became very active. And so then, as you said, peaking, but then in the recent decade, a lot of these coal power plants are closing down and the mines closing down also. But North American Coal Company still has a number of mines. They have, in addition to those in Texas, they've also got Five Forks in Louisiana and Red Hills in Mississippi, and we are collaborating with them to evaluate the rare earth element potential in these coals. So the one thing is the raw coal, the lignite, and the lignite in the Gulf Coast is similar to the lignite in the Williston Basin in North Dakota. So these immature coals, brown coals, the rare earths are associated with the organics and can be readily extractable. So, Brent, we've been making a career out of trying to evaluate the rare earth element distribution in these coals, and I guess, we find some hot spots, but a lot of them are just similar to crustal levels, but hotspot in Gibbons Creek. So To put it in context, the average crustal abundance of rare earth elements, and that includes the lanthanides and yttrium, is about 180 parts per million. And so the Gibbons Creek mine has up to 2,800 parts per million, but that's just a localized hotspot, and the Gibbons Creek mine is closed. And many of the others are similar to the crustal levels. But we have very few samples, Brent, so we have to keep going. We've only got about 120 samples, and I think the Williston Basin, they have, 2,500 samples because North Dakota is very supportive.
And
San Miguel, you
still,
mentioned that's low
yeah.
to moderate levels. So what do you think, Brent, is the potential of developing rare earth elements from the coal mines in the Gulf Coast and Texas specifically, but also maybe Louisiana, Mississippi?
Well, Gibbons Creek, those values that 2,800 ppm in total rare earths and yttrium, that's significant. It's significantly high. The only shame is that that mine is closed, and it's been reclaimed. It's gone through the reclamation process through the regulatory agencies, and so it's almost completely released all the way down to the last acre. And so, I'm not sure if the new landowners would be keen on the idea of reopening the mine and starting a whole new process, a new open pit mine like it was in the past. I think they're probably more interested in pasture land and leasing that land out for other purposes. But you never know. The economics could show it to be most useful or beneficial to be mining again. Otherwise, we have a lot of ash material or lignite material with low values, and even low values can be a resource if there's enough of it. I would think that if you have ash material or other material that's being mined elsewhere in the United States, like the Williston Basin or Powder River Basin, if you have seams that have elevated concentrations or look to be a higher priority for rare earth element operations or production, then more likely that those would be targeted first.
Right. Yeah.
It's just economics.
Yeah. Right. Economics drives most things, or nearly everything. So, we've got a huge resource of coal, 83 gigatons, as you mentioned, but they could potentially develop rare earth elements in the Gibbons Creek mine, but I think there's a lot of interest in non-thermal uses of coal, and so using the carbon for activated carbon or for soil amendments, humic acid, and other purposes besides burning the coal. So I think there is a mine in Louisiana that feeds into an activated carbon plant there. So I think that's also potential, right?
Yeah, there's a lot of different uses, and I think if we have other sources of energy, that may be cleaner or at least perceived as being a cleaner option, then I think it's an advantage to doing that and then turning these coal mines or coal resources into something else that's also a benefit rather than having to burn it. Of course, if you do have to burn it, you get ash material. We're always looking for ways to use that ash into the cement industry or into some other form that, is a trash to treasure or a waste to resource, mechanism, because the last thing we want to do is bury it somewhere when we could actually use it for something.
Right. And we're very fortunate that we have a strong collaboration with North Dakota and Nolan Thaker in North Dakota. And so they have done a lot of research in extraction of rare earth elements from the raw coal itself and find that, the extractability is 60 to 80%. So very easy to extract with the environmentally benign weak acids. So that wouldn't cause problems. So if they do decide to develop, and North American is interested in evaluating the potential from their active mines now. So that's a possibility. And in contrast, the extractability of the rares from other coals like the Appalachian coals, Appalachian and Illinois basins is much lower and requires much stronger acids. So that's going to be more complicated. But the Powder River Basin, also those coals may be more difficult to extract the rare earths. So you mentioned coal ash in power plants, and Bob Reedy did an analysis of coal ash throughout the U.S. and found that, coal and coal ash, looking at the linkage between the coal source and the coal ash where it was produced. And I guess figured out maybe about 52 gigatons of coal consumed in the US from the 1950s to 2021. And about 10% of it on average becomes ash. So that's about 5.3 gigatons of coal ash throughout the US. But that varies a lot from about 6% coal ash in subbituminous coals like Appalachia to 14% in the lignite in the Gulf Coast and North Dakota. So I think he found that, maybe 70% of the coal ash hadn't been sold or used on site. So it's potentially accessible and has been disposed of in ponds and landfills. So maybe you can describe that a little bit, Brent, and previous studies by Taggart and others had looked at the rare earth element concentrations in the coal ash from those sources.
Yeah, so that ash has to go somewhere. If you're not using it for some other purpose, like in the cement industry or road-based material, there's a number of potential uses for the burned material. One interesting thing, there's those concentrations, like I remember like high Appalachian coal being about 585 ppm, whereas Powder Basin around 330 ppm total, where it's in yttrium. That's very similar to a lot of the conventional, say like Round Top out in West Texas, a conventional rare earth elements resource of igneous rock that you would mine it. You'd have to basically mine it and crush it and acid leach it and be able to get out pretty much the same kind of ppm per ton of material as you would with some of this coal material or ash material that's already being produced, right? And already in a state that you can be readily leachable compared to those hard rock sources. So it just makes sense to take on these waste materials and get the rare earth elements out of that rather than going to a conventional source of a low grade. Typically a low grade, if you consider that a low grade for a hard rock material. If you think about lithium and pegmatites, for example, would be 8%. That's a huge number for a commodity coming out of a grade of ore material. So taking advantage of the ash material into these coal resources, if it's trapped in the organics or in the actual coal, that's and it's already being mined. We're taking advantage of the workforce that's already there. The mine's already there, the material's already being produced. It's a no-brainer as far as taking advantage of it, since it's already being served up.
Right. And I mean, the coal ash from the Appalachian coals and Illinois coals, it's the extractability is fairly low, maybe 30% with the strong acid. But the Powder River Basin coal, which has been distributed throughout the US, the extractability is much higher, maybe 70%, because it has high calcium. So that's an advantage. And Department of Energy, NETL lab have been doing a lot of work about extracting rare earth elements from coal ash from the Powder River Basin. So some of the power plants in Texas, they have burned a variety of different coals, Appalachian and Powder River Basin coals, in addition to the lignite at the mine mouth plants. So I think Bob Reedy estimated that about 0.3 gigatons of coal ash was produced from lignite in the Gulf Coast over a long time. And as you said, when you burn coal, you concentrate the rare earths. So on average, what we found is that the rare earths were about 4 times more concentrated in the coal ash than in the raw coal. But then the extractability is much lower. And so they kind of balance each other out. The extractability from the coal ash is much lower than the raw coal. But if we estimate the rare earth elements, the oxides and the value of those is estimated to be about $1 billion, and the value from the heavy, the permanent magnets, the rare earth elements that become permanent magnets, is almost $0.9 billion. So I think you're correct that we should take advantage of this, hopefully, And then, the other regions, a lot of these power plants are near rivers for cooling and near shallow groundwater. And so there may be some contaminants leaching into the water. And so there may be an interest in moving that ash to a safer resource for environmental purposes. What do you think about the reclamation status and offsetting contamination, Brent?
Yeah, so it's a liability, certainly, and it's always been a liability and it takes monitoring for decades, as part of a mine's reclamation plan. So, they burn that coal, the coal may go back on site or maybe go off site, but it's into an impoundment somewhere, or a surface impoundment that has to be monitored, because you have to monitor groundwater contamination or potential for groundwater contamination. Hopefully those pits are lined, and then we're storing that ash material over time, just as a waste material that has to be monitored because of the potential for contamination. We've had a number of cases where those impoundments, you have flooding events, and then those impoundments break, and then you get, ash washed across the surface somewhere, and then we have land surface contamination as well as, potential groundwater contamination. So it's a risk and a liability to have that material just sitting there. So it makes sense to use it for something, and if we can get something good out of it, like rare earth elements or critical minerals, then and alleviate that potential for risk from those impoundments, and that makes total sense.
Right, and the production of rare earths could offset part of the remediation costs also.
Yeah, definitely.
And I think, when we look at the economics of developing rare earth elements from coal or coal ash, I think the techno-economic analysis underscores the need to develop co-products. And so, because, if you think in Texas, maybe average price of lignite is about $20 a ton, and the value of the rare earth elements is maybe $3 or $4 a ton of coal. Certainly important to develop additional co-products. What are your thoughts about that, Brent?
Well, already, with the production of activated carbon from that, ADA location in Louisiana, so we have that potential, humic acid and amendments, like I said, there's that kind of material, any kind of, synthetic carbon materials that can come out for water filtration systems and using the activated carbon, for example. I mean, those are all, great, kind of co-products that can be done in some of these coal mines, but then, a lot of the ash material also has potential for things like iron and titanium and, major elements besides the critical elements or rare earth elements that can come out of it. There's a lot of potential from that material because it's already in a concentrated form once the burning of the coal happens. And so there's a number of companies that are looking at new technologies, chlorination, for example, of ash material in order to remove those metals. And that again offsets the costs of the coal, or it is additional revenue stream, in addition to like rare earth elements, critical elements, scandium, for example, things like this that may be inside the coal material. So if we can get as much of these different mineral commodities out of that material as possible, then it benefits everybody. And
right. And another possible co-product is synthetic graphite. And I think there's a group in Wyoming that are looking at developing other carbon materials. Any thoughts on that relative to mining natural graphite?
Well, it's more energy intensive, it's more expensive, or you can take either graphite material and make graphene, other kinds of products from the graphite as well. There is a shortage of graphite. Graphite's on the critical mineral list, and so it's it may be used for more specific things other than the coal product. I don't know. I haven't really thought about using the coal products as long as we have graphite mines and graphite availability. But I guess it could be a co-product if you want to take advantage of it.
Right. Well, partway through the Department of Energy project, then they expanded the feedstocks that we could consider. And So, Brent, maybe you could talk about a little bit about some of these other potential feedstocks, particularly the red mud from aluminum processing in the Gulf Coast.
Right. So,
Maybe you could provide some background on that.
yeah, so we have a number of places across the Gulf Coast, and two of them here in Texas at Copano and Point Comfort along the coast that were part of the aluminum processing of bauxite material, and then the waste product that comes off of that is a red mud, right? So we typically just call red mud as bauxite residue. Yeah, to the Bayer process, and then we get that material and they get stockpiled because it typically has a high alkalinity, has a pH of around 11 to 13, so it's caustic. It's not great material when it gets pumped out as a sludge onto these giant impoundments. And we have a number of these locations that along the coast, and most of that material is coming from either Jamaica or Brazil or some other location, and we process it here in the United States, and then have to host that waste material over time. So it'd be great if we could find a use for it, and through our efforts through the CORSIUM project, the Carbon Ore Rare Earths Critical Mineral Project with DOE funding, been able to analyze a number of those samples from here in Texas as well as in Louisiana. At Gramercy and Burnside. And so those have, pretty high levels of rare earth elements, at around 2000 ppm at Gramercy and over at Copano, and about an order of magnitude less than that, around 200, or so ppm over at Point Comfort location. But 2000 ppm, that's pretty significant, as far as the concentration of rare earth elements in yttrium inside a waste material that's just sitting there in the impoundment again, that could be used for something useful. And I think that group, Element USA, out of was operating the Gramercy location. They moved their offices here to Austin, and I think you had Chris Young on your podcast before, and so I guess listeners can go back and listen to that podcast and about all the interesting things that they're doing and the innovation they're doing here at their Cedar Park location in Austin, just north of Austin. But they can get other co-products like iron out of that, that waste material, as well as finding ways to remove things like the rare earths and yttrium, scandium, things like this in the red muds.
Right. Yeah, I think it's extremely promising. It seems to me the most promising source of rare earths that I have come across in terms of waste.
From a waste material that has been sitting there for a very long time and would sit there for a very long time unless we do something to take advantage of it more than likely.
Right.
Some of the other kind of waste materials.
Before we get on to the other stuff, I mean, the Copano site and many of these coastal sites are near the coast, or they're within, shallow, or a couple of meters near sea level, so environmentally very vulnerable. And so, managing these waste resources would be very important from an environmental standpoint. And you mentioned both Copano and Gramercy from Louisiana. If we estimate that the rare earths in the crustal rare earth levels about 200 parts per million, so Copano median value of about 2,000 parts per million, so 10 times crustal, and then Gramercy is about 4,000, but we have limited samples from Gramercy, and I hope you're going to rectify that in the near future. So that, and then talking to some people about extracting rare earths from these products, they say they can get up to 80% extractability, and also the rare earth elements are pretty uniform. All of them are high, including scandium, which is probably the most valuable rare earth. So a lot of interest in scandium for defense and stuff. So really, really promising. But there are other sources also in Texas, Brent.
Yeah, so beyond the kind of the red mud as a potential source for rare earth elements or critical minerals that can be they're easily accessible, and it's a waste material that's sitting there impounded that we could take advantage of. Heavy mineral sands is another opportunity. There have a number of sand mines that have kind of gone through some struggles as of late. The sand industry or industrial sand industry for fracking. It has its ups and downs, and depending on where you are in the country is where you kind of source your sand material from. So like the Northern White Sands used to be a pretty heavy provider for that frac sand material, down here to Texas. And then we also had the Central Texas kind of sand district with industrial sand mines that were feeding into that. And maybe a little lower quality, but kind of very similar in age and quality of material. And then we had a whole lot of mines that opened up in West Texas to facilitate the fracking operations in the Permian Basin in more recent years, and that's kind of driven the cost down for a lot of that material to the point where a lot of these mines in Central Texas, for example, can't compete. And maybe even the ones in the Northern White Sands and coming from Minnesota and Illinois and Wisconsin, for example, can't compete with some of that low cost material they're getting out there in West Texas. And so, those industries, at least here in Texas and Central Texas, are looking for any kind of opportunity they can do to find, revenue from their sand resource. And so heavy sands, things like zircon and monazite and zeotime, leucazine, there's a whole lot of different materials, the titanium, oxides, for example, are all within these heavy sands as a fraction of that mined material is a waste product, is not really using it for fracking. So, the heavy sands in Central Texas is one potential source of earth elements, and it takes up about 1 to 2% of the total, mined material, the tonnage of material that's there in, of the sand resource. And about 4% of that material, the heavy sands, is rare earth elements and yttrium.
And that's from limited sampling, though, right, Brent?
Yeah, limited sampling, right? Limited sampling, but all indicators show that it's fairly homogeneous, at least within these Cambrian Ordovician sands that are on the basement rocks. So I wouldn't say that would be the case for all sands, all industrial sands across the state, but the ones that are basically in close association with the Precambrian basement rocks, that they're
the Llano uplift area.
Yes, or places that are very similar to these Cambrian Ordovician sands like that. They have probably more potential than others, and we've done some preliminary studies and kind of done some estimates on how many mines we could possibly open in high potential areas there in Central Texas, and it's a potential for a lot of material that would be already being mined, and you just have to be basically mechanically filtered or sorted. And then you'd have a feedstock of, relatively high potential. We're talking 40,000 ppm, 4,000 or 4% material. That's pretty significant if you can, spend the money to mechanically separate it.
Right. And Julia, you were involved in research on hydraulic fracturing in the past, and I know from my work that they over time they increased how much frac sand they were putting down hole to, but using cheaper sands rather than the Wisconsin sands or the high quality sands for fracturing the rock and then they were able to get it locally from the Monaghan sands and other things that don't have that are not heavy mineral sands.
Yeah, the Aeolian, they're sand dunes that are out there that are relatively young.
Right.
Yeah, and the other angle is the activity in the different basins. So one of the reasons why all the sands from the Brady area were so popular was because they were able to feed the Fort Worth Basin activity in the Barnett Shale. That's still going, but it's not as active. Well, it's still active, but there's not the requirement that there was. And so now the big volume is out in the Permian Basin, as Brent mentioned. So, when you've got bulk materials like sand, the amount of distance that you have to transport it is a big driver of where you're going to get the sand from.
Right. And I think there was a trade-off between the quality of the sand and how much sand they put down hole. So they put a lot more propant over time and more water for fracturing over time. And then they kind of plateaued at a certain point, but they increased that because they figured out that they could use low quality sands if they use more of it.
Yes, the art of proppant placement and actually knowing where it's gone, and the hydraulic fracture system is far from set, shall we say. So there's many factors, but the big driver is the Permian Basin activity.
Right. And Brent, you've been involved in the lithium work also in East Texas, and that extends from Arkansas. Maybe you can describe that a little bit and the potential for that.
So we put out a paper, JP Nico and Roxana Devare, who kind of work on the oil field brine chemistry characterization across the state as part of their work here at the Bureau. We put out a paper back in, I think, the early part of 2024, I believe it was, that showed distribution of different chemistries of those brines from the Anadarko Basin, the Permian Basin, the Eagle Ford, the Haynesville, the Barnett, the Anadarko Basin, and all the different basins across the state to show the different variations. And so some of that work combined with the USGS brine database data that has been around for a long time, they keep updating it with newer, kind of better data. Shows that this Smackover has a very high potential for lithium production. I think everyone's familiar with kind of the boom of lithium over in Arkansas in the south and southwest part of Arkansas. And that trend goes all the way down into northeast Texas and kind of bends down towards the south into eastern Texas. And so Standard Lithium has drilled wells, and they've put out some notices. They had over 800 ppm of lithium within some of their brines that they drilled. So it's when you look at like South American brines that have about 1,300 ppm, that's for oil field brines that are in constant production every day. Those are pretty significant numbers for the volumes and already in kind of a concentrated form coming from a natural formation like that.
Right. Yeah. And I know there's interest in lithium in the produced water from the Permian, and they produce lots and lots of water in the Permian Basin, but the concentrations are pretty low, maybe average concentration, maybe 20, 30 parts per million. But if they improve the extraction technology, or, they're going to be treating that produced water anyway for other purposes, they may be able to extract the lithium from that also.
And so in economic geology, you can have a high grade resource and you produce very little of it, kind of like these, Smackover volumes, very low volume but high concentration. Or you could go after something that's a low concentration and high volume. Certainly in Permian's, how many billions of gallons are produced over time? It's a lot of volume of water, that they would have to take out of the ground with those low concentrations. But like I said, if extraction technology is there, and they have an easy way of actually producing a lithium carbonate or lithium chloride or some other lithium product out of that, then certainly if it's economical, they'll do it.
So one of the advantages of all of this development in the Gulf Coast and in Texas is that the coastal location is very advantageous. There's a lot of infrastructure to support rare earth element development and critical minerals and other mineral resources. So, you mentioned Element USA, and I think also Linus is developing a processing plant near the coast, and others. Maybe you can describe the processing, because processing is as critical as finding the source of rare earth elements in the US. Being able to process it also is extremely important, because currently a lot of it is processed in China. And so we don't want to just find the resource and then send it to China to process. So.
Yeah, certainly we have our major bottleneck within the United States, I think, is processing. We've worked out enough of the kind of extractive technology, so I think people have demonstrated they can extract it. Maybe not as economical because we have more restrictions and more regulatory aspects to deal with than, say, China or somebody else. They can do it cheaper, on the extraction side around the globe. We do have a lot of coasts here in Texas, and we have the ability to kind of bring in materials or use domestic supply materials, and then we can import or export. And so having Linus, have that DoD contract, whatever, a couple $100 million from DoD to or to help them build that facility for rare earth element extraction along the Texas coast at Seadrift is a big deal. So expect to be able to produce a lot more material once they're already in operation. They have other facilities around the globe already, so they know what they're doing, and they've shown that they can do it in other locations. And so having it here in Texas should be a real game changer for moving materials here to Texas to process and then move them to other locations. We have a number of companies that are, startups like Element USA here in Austin. There's also, Maverick Biometals that's down in San Antonio. They're looking at enzymes and kind of using biology to extract metals and other things in the subsurface or from materials from feedstocks. So there's a lot of different groups that are really starting to do the production side of things. Either like Element USA is a middleman, they're a concentrator. They'll take that feedstock, they'll turn it into a concentrate, and they'll take it to someplace like Linus, for example, and have a product, either as an oxide or a carbonate or a phosphate or whatever the end product is that the industry can use to make microelectronics or medical equipment or whatever you have.
Right. And, when you were talking about the aluminum processing in the Gulf Coast and Copano and these other sites, that was importing bauxite from Jamaica and some from Brazil and stuff. So the coastal location is extremely advantageous. And I think Linus maybe might import feedstock from Australia with some of their current production there to start off, I would think.
Yeah, from Australia, and then I think they had locations in the Caribbean that also have potential as a feedstock that can come in.
Right.
A more central location.
Yeah. So a lot of things happening, and we had the critical Marek Lukmelis at the department, the Jackson School of Geosciences, and also with the Bureau. Had the critical mineral conference recently that he hosted with NSF in Austin. Do you guys have any comments on that? I found it extremely interesting and learned a lot, and it was great to see the variety of topics being discussed.
Well, I think it's one opportunity for most people. A lot of times you go to a conference and it's focused on just resources or just extraction or just policy. And this one actually brought in all the speakers were from different areas. So you had industry, you had policy and regulatory framework discussions. You had resource and people who are actually doing the mining, people who are actually doing the processing. So if you get everybody who's in the supply chain, together in the same room to have those discussions where everybody can see where everybody else's pressure points are, I think a lot of the kind of solutions can be reached a lot faster than if you just had, a silo of content or a silo of a certain focus, like a lot of conferences are focused on. So I think we need more of these unsiloed, full spectrum, workshops. We call it a workshop, not actually a conference, right? That way we could actually come to some kind of result or some kind of conclusion and make the connections with the people you need to make connections with.
And how did you enjoy it, Julia? What did you?
Yes, following on from what Brent said, I would look at it from another angle, which is the spectrum of expertise that was there in terms of experience. So you had everyone from a very, very senior person from USGS who's been doing this kind of evaluation for decades to the very newest students. And coming back to the workforce development, these kinds of workshops are going to be very important to bring students on, to expose them to the range of topics that have to be tackled. And, sometimes we're getting students who have mixed expertise. So somebody might have expertise in geology and policy. And whilst that might seem strange bedfellows in this particular space, it's actually something that might lead them to be able to develop a career that was quite meaningful. So I enjoyed it a lot from lots of different perspectives. But in the Jackson School, we've started the hiring process because for a very long time, economic mineral resources was kind of a smaller effort. And Brent and Rich Kyle and people like that were soldiering on there by themselves. But now we're starting to look at hiring more people and developing a portfolio of skill sets. And then I think that's probably going to be true across UT, because there's all the people in engineering and in policy that could also contribute.
Right. And, Mark Millis and Daniel Alessi, focusing on lithium and all of the lab equipment and everything. And then having Element USA down the road, and they would be hosting a lot of the people. They, offer to host various people to test out the extraction processes and everything. So it's a really exciting time. And I guess, do you guys have any last minute comments? I'm really excited about the report of investigations, Julia, and I think that would be a huge plus. And also the web portal is just incredible. So
Yeah,
any closing comments?
Yeah, I think, I come from mostly working with oil and gas companies on geological problems. And the model that we found that's very successful in academia is to have input from industry, often in terms of consortia. So we have multiple companies buying into a particular project or topic area. And then we also sometimes have bespoke overheaded projects, but the industry academia partnership is going to be fundamental in terms of research. And I see we have a lot of experience of doing that in oil and gas at the Bureau. And so I think that some of those models can be taken forward to allow that kind of partnership to flourish.
And also Brent worked previously at the Railroad Commission, so you have a good understanding of the regulatory side of things. So that's very helpful also.
It's kind of the Wild West for minerals right now here in Texas, because coal and uranium is regulated by the Railroad Commission, but a lot of the other commodities and metals mining and rare elements, even lithium from brines, is all new. So we're making the rules up as we go now, and it's becoming more and more important as we're recognizing that those resources are here and there's a lot of potential from these waste materials. And so the regulatory side of it, the policy side of it, those are all vitally important right now in the scheme of things, and in order to make things happen at a rapid pace, because we need it yesterday. We don't need it 10 years from now, where it typically is like the typical time frame for regulating a mine, right? But if we have waste resources that we could get out now and get it produced, that's kind of vital to our domestic security for critical minerals.
Well, thank you both for participating in this podcast, and I will include material on the website with links to resources and papers and to the workshop and all of that, so people, the listeners, can access all of that. And looking forward to more discussions. Thanks a lot.
Thank you.
Thank you.